Welcome to 10.9. This is our last lecture for the Unit 10, and we're going to talk about balancing chemical reactions and about the law of conservation of mass. So what I have here is a reaction. It's a decomposition reaction where water breaks down into hydrogen and oxygen. So I'm going to go ahead and write out the formula. So I drew it out for you. Here's one molecule. This is one molecule of hydrogen. One molecule of hydrogen means that there's two hydrogen atoms bonded together. And we have the same thing over here with oxygen. Oxygen's bonded with another oxygen, and we have one molecule of oxygen. So this is how we would write the equation. It's a decomposition equation. But if you notice something about what we start with and what we end with, remember reactants are what you start with. So this is what we have at the beginning of the reaction. At the end is what you see on the right. Now, what do we notice about the difference between what we see at the beginning and what we see at the end? Well, we can tell that at the beginning, at the start, we have two hydrogen atoms, right? And we have one oxygen atom. But at the end, we have two hydrogen atoms and two oxygen atoms. And even though it's correct that water will break down into H2 and O2, what isn't correct is the fact that we seem to have gained one oxygen atom. And according to the law of conservation of mass, that is impossible. Atoms are neither created nor destroyed in ordinary chemical reactions. So what does that actually mean? It means that whatever number of atoms you have at the beginning is also the same number of atoms that you have to have at the end. So the same number of atoms of each element must appear on each side of a correct chemical equation. Let's go back to the equation I was just talking about. Do we have the same number of atoms at the beginning as we do at the end? The answer is no, we don't. We have more atoms at the end than we do at the beginning. And so that means that this is not exactly actually what happens in real life. In order for us to have the same number of atoms on both sides, sometimes you have to add molecules to get a balanced equation. One thing you can never change are the subscripts. So the numbers that you see here are numbers that you cannot change. Okay? These numbers are permanent. Okay? What is going to change, I don't know why these keep happening. What is going to change is the number of molecules. So since we have two oxygen molecules at the end, we need to have two oxygen molecules at the beginning. How do we add more oxygen molecules? Well, I can't add a single oxygen, otherwise it changes my reaction. But what I can do is add a whole another water molecule. So what happens if I add another water molecule? Okay, if I added another water molecule, now I have two oxygens at the beginning and two oxygens at the end. But what happened to my number of hydrogens? I've now gained two hydrogens. So instead of two hydrogens, I now start my reaction with four hydrogens. So that means my oxygens are balanced, but guess what's not balanced anymore? My hydrogens aren't balanced. So I need to add more hydrogens to the end, because I had four in the beginning, so now I need four at the end. Well, how can I do that? Well, I have one hydrogen molecule here, which is composed of two hydrogen atoms. So let me see what happens if I add another hydrogen molecule. If I add another hydrogen molecule, now you see that instead of two hydrogen atoms, I have four hydrogen atoms total. So what does that look like when we're looking at the equation? If I wrote this out, I would say, in order for this reaction to really happen, I would need to start with two molecules of H2O. Do you see how I have two molecules of H2O here? And then how many molecules of H2 would I need? I would need 1, 2. So I put a big 2 in front of the H2, meaning I have two H2s. And it's going to produce how many oxygens? Just one oxygen. So you can put a big 1 here, or you can leave it blank. Because remember how I said that whenever you don't see a number, we just assume it's 1. These big numbers are what we call coefficients. Coefficients basically tell us how many molecules we have. So if we start with two molecules of water, we can end with two molecules of hydrogen and one molecule of oxygen. Alright, let's go ahead and balance some more equations. Okay, in this problem, I have one molecule of CH4. Here is an example of one molecule of CH4. It has one C inside of it, and it has four H's on the corners. That matches the chemical formula right here, 1 C and 4 H's. If I add it to one oxygen molecule, that means I have 2 oxygens in that one oxygen molecule. If I add these two together, they're going to rearrange, the atoms will rearrange themselves and rebond themselves to form one molecule of carbon dioxide, which is made of 1 carbon and 2 oxygens. And it will also produce 1 molecule of water, which is made of 2 hydrogens and 1 oxygen, as you can see right here. So how are we going to even out the numbers? How are we going to make sure that it's balanced? Well, I like to keep a tally of how many atoms of each element I have at the beginning and at the end. So my beginning is what I call my reactants, okay? So my reactants are on the left-hand side, and my products are on the right-hand side. So what are the elements that I start with? Well, I start with carbon. I also have hydrogen, and then I also have oxygen. And notice you should have these same elements on the product side: carbon, hydrogen, and oxygen. Okay. Keep in mind, guys, that there are 2 places that you have oxygen on the reactants. You can find oxygen in carbon dioxide, but you can also find the oxygen in water. Okay, so let's go ahead and count. How many carbons do we have at the beginning, at the reactant side? Here's the reactant side. How many carbons do we have there? We only have 1, so I'm going to put the number 1 there. How many hydrogens do we have? Well, this number 4 stands for our number of hydrogens, so I write 4. And how many oxygens do we have? We have 2 oxygens. So that's the total number of atoms on the reactant side, or the starting side. How much do we have in the products? You can see we have 1 carbon, we have 2 hydrogens, and when we're counting oxygens, you have to count it in both places. So you have 2 oxygens from the carbon plus 1 oxygen from the water. So we have a total of 3 oxygens. Okay. So now I'm going to go ahead and balance it. Well, how do you know which element you're going to balance first? Well, if you see, carbon is already balanced. We have 1 on both sides. Hydrogen is imbalanced, and then oxygen is imbalanced. So how do you know which one you need to even out first? Do we even out the hydrogen atoms, or do we even out the oxygen atoms? Well, here's a rule of thumb. If you ever have an element that is by itself, you want to save that one for last, because it's really easy to balance out an element that's by itself. Hydrogen, you can see, is in a compound on both sides, so we're going to even that one out first because it is typically harder. So we have 4 hydrogens to begin with and 2 at the end. Whatever side you have fewer hydrogens on is going to be the side you want to add hydrogens to. So since I only have 2 hydrogens on my product side, I want to add more hydrogens. What I'm really doing is I can't change this number, but what I can do is change the number of water molecules. If I have 1 water molecule, I have 2 hydrogens. But what happens if I say that I have 2 water molecules? Now how many hydrogens do I have? Well, the coefficient number you're going to have to multiply by the subscript number. So 2 times 2 means that instead of 2 hydrogen atoms, I now have 4 hydrogen atoms. Now how many oxygens do I have? Well, you're going to take your coefficient and multiply it by the 1 oxygen you did have, and now you have 2 oxygens from the water, and don't forget you still have 2 oxygens from your carbon dioxide. So now I have a total of 4 oxygens. Okay, so now my hydrogens are balanced. What do I still need to balance? Well, now I need to balance my oxygens. Okay, how do you balance out oxygens? Well, which side do you have more oxygens on? The product side. I have 4 oxygens on this side. So that means I need to add 2 more oxygens to my reactant side. How do I add 2 oxygens? Well, each oxygen molecule comes with 2 oxygens. So if I just add another oxygen molecule, now how many oxygens do I have on the reactant side? Well, if I multiply, I see I have 4 oxygens on this side. So I am now totally balanced. We have a reactants and a products. What reactants do we have? We have potassium, chlorine, and oxygen. We have the same on the other side. Okay, now let's go ahead and count our reactants. We have 1 potassium, 1 chlorine, and 3 oxygen. So 1, 1, and 3. On the other side, we have 1 potassium, 1 chlorine, and 2 oxygens. So 1, 1, 2. Okay, so right now, the only thing that we need to balance out are our oxygens. This one's tricky because it's not like we can just add one. Which side, we want to add more oxygens to this side because we have 3 oxygens here and 2 oxygens here. So we want to add more oxygens. But guess what happens if I put a 2 here? That doesn't give me 3 oxygens. It actually gives me 4 oxygens. So that means I'm still not balanced, right? I'm going to change that to a 4. So what do I do next? Well, if you added more oxygens on this side, how many oxygens does that give you? That gives you 6, so you're still not balanced. So here's what I'm going to have you do. If you get one of these where you have a 2 and a 3, if you get one of these where you have a 2 and a 3, the best thing is to find the least common multiple, which is 6. Okay, so I'm going to try and make both of these oxygens have 6. So in order to have this side have 6, I need to put a 3 here. In order to have this side have 6, I need to put a 2 here. So 2 times the 3 equals 6. So now everything's balanced, right? Well, not quite. Because this 2 doesn't just affect the oxygen, it also affects the chlorine and the potassiums. See, so now I have 2 potassiums on that side and 2 chlorines, which means my potassiums and my chlorines need to be balanced out. So, since I have 2 potassiums and chlorines on this side, I need to have 2 potassiums and chlorines on this side. So, if I just added 2 here, guess what that does? It makes 2 potassiums and chlorines on my product side. So now I'm completely balanced. Before we get started, I want you guys to know that there's a typo. It should be Fe2 parentheses SO4, and then outside the parentheses you should see a 3. Okay, so go ahead and make that change. Alright, let's go ahead and count. What do we have on the left side? I have iron, oxygen, hydrogen, and sulfate. So iron, oxygen, hydrogen, and then SO4 is one thing, that's sulfate. Okay, how many of each do I have? Well, I have 2 irons. I have 3 oxygens. Notice I'm not counting the oxygen in sulfate, okay, because that's a separate thing that I'm counting. I have 2 hydrogens, and I just have 1 sulfate molecule. Okay, on the other side, I should have the same elements in the same order. Okay, how many irons do I have? On this side, you can see I have 2 irons. I only have 1 oxygen that's in the water. I have 2 hydrogens in the water, and then I have 3 sulfates. So, right now, iron and hydrogen are balanced, but oxygen and sulfate aren't. So, as a rule of thumb, oxygen and hydrogen are going to be some of the last things you balance. So the first thing you want to balance right now is sulfate. Okay, so if I have 3 sulfates on this side, I want to have 3 sulfates on this side. If I add a 3 here, guess what that does? It tells me I now have 6 hydrogens, and it tells me I now have 3 sulfates. Let's go ahead and change that 1 to a 3, and this 2 to a 6. So my sulfates are balanced, but my hydrogens and oxygens aren't. So which one are you going to balance next? Well, honestly, it doesn't really matter. You're just going to choose one to balance out first. Let's choose oxygen to balance out. I have 3 oxygens on the left side, and then I have 1 oxygen on the right side. So I want to get 2 more oxygens on the right side. So if I change this coefficient to a 3, it tells me I have 6 hydrogens, and now how many oxygens do I have? I have 3. So let's go ahead and change those numbers. And I have 3 oxygens, and I have 6 hydrogens. So sometimes when you're just trying to balance out one thing, like oxygen, you accidentally also balance out hydrogen.